All right, first section was about polynomials just in general, right? So we had, we looked at ways to classify a polynomial into kind of smaller versions of that, but we realistically could call everything a polynomial, right? And that's what we found out. So a polynomial is just putting a bunch of monomials together, and how do we separate them? With a plus or a minus sign, right? Excuse me. And again now, what is a monomial?
Number, a variable, or a product.
A number, a variable, or a product, right? And again, when we talk about that variable, it can be a variable with different exponents, and that makes it a different term, okay? So in number 9, would you say number 9 is a polynomial? And what kind would we say it is? A binomial, right? So we'll get into binomials a lot next year, or you will. Okay? Number 10 is a monomial, right? What about 11?
Yeah.
But there's more than one thing in there. But it's not split up, right? So that's just one thing too. Number 12. It's not one because why? The variable's on the bottom of that fraction, right? Whenever the variable's on the bottom, we say then it's not a polynomial at all. Excellent. Number 16. 16 is my trinomial, right? And why can't I add 5x squared plus 3x? X is squared, exactly right. So we basically have a brown cow and a black cow. They're not exactly the same. Okay, so then the next section of that section was about the degree of polynomials. When we talk about the degree, we're talking about each individual monomial in a problem, right? So in some of them, it's pretty easy because that's the only thing that's in there. Like number 19, there's only a monomial in the whole problem. So what do? We count up all of the exponents and add them together. What about the coefficient? Does that have anything? No. Whole numbers or constants don't really have a number, or in this case, a coefficient. So what did we say about something like 19? 3, right? That would be my degree, right? I'm taking 2 from the A and 1 from the B, all right? Then in something like 22, we basically do the same thing, but then we look at them as individual monomials. So we're looking at combining, or don't then add them together at the end, right? So what is the degree for 22? 3. It's 3 also, right? Because the first one would have had just what? 2, and the last one would have had 3, so it's the bigger of the 2. But again, remember, don't add them together. How about number 24? 4. Perfect. Any questions with those? You are.
I've been a golf job.
We saw it.
What do you do?
You don't want to know.
Yeah, no.
Number 30, or next section, adding polynomials. So the most important thing about adding polynomials is what?
Exacting like terms.
Like terms, that they're exactly the same variable, right? And exponent. Okay, so what do we actually add together?
Add and subtract the coefficients.
We actually add and subtract the coefficients or the number in front. So then you got to stop and you got to think about all of your rules, right? If I'm adding and the signs are the same, I add and use that sign. If I'm adding but the signs are different, I actually what? Subtract, and then I use the sign from the bigger one, right? So even though that it's a negative number, we know that negative number can never be bigger, but we would use its sign, okay? If it's subtraction, the most important thing is realizing what is being subtracted. So you got to look at, in like number 34, that minus sign is in between the parentheses. So we're going to still do keep, change like we talked about at the beginning of the year, but you got to change everything in that second parentheses. All right, so again then, if you notice in 25 through 29 and 30 through 34, they do it a couple different ways, right? They do them as vertical problems, which we would have done way back old school version when we first learned to add and subtract, or you can just do it horizontally like they would have done in 33, 34, and 28 and 29. That's totally up to you. So realistically, can I show work in this? Maybe, maybe not, but you should try to show it as much as possible. So, do you need to see anything from 25 through 34?
You did 29.
29, let's do negative 3y squared. So which way do you want to do it? Vertical. Was it plus 2? Okay. I'm going to, if we're going to do it vertically, I'm going to spread this one out. Will somebody read the second one?
4y squared
4y squared. Okay.
minus 5
Minus y.
minus 3.
Minus 3. So the only reason I left that little space there is because the first one didn't have a y, right? And what kind of problem is it? It's a addition problem, so I had a giant plus sign. Now again, you don't have to do it this way. If you wanted to just look at it in there and combine terms going across, that's totally fine. This way is pretty, it shows exactly what you're doing, so this is kind of a good method if you're struggling with this. And then wherever that space is, I'm always going to put in a 0. And now I'm looking up and down, right? I'm always looking up and down. So what's negative 3 plus 4?
1y squared.
1 or just y squared. Perfect. 0 plus negative y. Negative y. And then 2 plus negative 3. And again, it's not wrong, but we want to try to write it in descending order or alphabetical order. So this one's in the right order, right? Y squared is the biggest term in the problem. Okay. Any in the subtraction ones or another addition one? We all good with that? So again, when we subtract, just make sure we subtract everything either on the second level in the vertical ones or the second parentheses in the last two. Okay? So then we go to 13.4, which is our last section that we had talked about. And as Addie said at the beginning, when we're multiplying, we are adding the exponents of the variables that have the same base, right? Only the variables with the same base. And again, the base is the variable part, right? So then we would take the exponents and add them together. Here we think about rules that we did way back when, and those two rules were if the signs are the same, my answer is what?
Positive.
Positive. If the signs are different, my answer is automatically
Negative.
negative. Doesn't matter which one's bigger or smaller, doesn't matter which one comes first. Okay, but I'm multiplying. So, again, the difference between 35 and 36. If you don't like 36, how they wrote it, with the 7 on the backside, then you just put it out in front and do the problem. Okay? And these aren't real difficult, I don't think, but do you want to see one of these, or do you want me to make up like a harder one? Make up some hard ones? All right. So, we'll make it up really hard. So, 4 a squared. Is this a good one?
Yeah, it's too long. Run off my finger.
All right, try that one. make sure you tell Grace that we're gonna do the testing. Okay?
Yep.
Too easy?
Yeah.
Yeah.
It was just a bunch of numbers you had to carry over. That hard.
I got this.
I'm getting smarter, I moved away.
Yeah, I know.
I got this done easily. There's a lot of sixes.
That was? Oh, the answer?
1, 2, there's only 2.
There's only two.
See, that's only if the people at that time.
You're not.
No, I only had two. I had 2 sixes.
How did I?
And then there's an EMP in there.
Yep.
Yep.
Agree?
Yes. Sir. We should do a really hard square root of something.
Square root.
You mean like just coefficient would be a square root?
Alright, we'll do one more.
I'm not even going to do those.
We'll make it bigger numbers so you have to do some math.
Why?
Just take something.
Alright.
Oh boy.
No calculators.
I'm not using one.
You know what?
Why did you guys do that?
Done.
Oh boy.
Sir.
getting smarter.
I am getting smarter. Maybe if I moved to the corner, I'd be the smartest kid in this classroom.
But Alec isn't though, so I don't understand. Why is Addison like sitting behind me and then Laura's over there and they are
I'm as smart as them right now.
yeah.
If I backed up a little more, I would be smarter.
You are
Finish your sentence, Meadows.
you are what's all little people
How do we do?
good are like 2% smarter than I am. 2%, only 2%. Yeah, I just don't use. I mean,
One
I'm
more?
smart.
No.
Caleb, no.
It just takes forever. That's what makes me mad.
Then we're doing one more for Caleb.
Make it extra long.
Extra long?
Yeah.
Make it.
No calculators.
Make it
Yeah, people who use that
Make
calculator.
it 5.
5 in here?
Yeah.
Alright.
At least.
Nobody can start until it's all written down.
And they have to be over all triple digits.
But can we write it down?
You can write it down, but don't start until everybody gets it.
Okay, but I can't see. Okay.
Yeah?
I don't have enough room to make 5.
But 2. Minus.
To the 47.
1/3.
Uh-oh, I might not have enough room either.
Can squeeze it in
No,
there.
I'm not
What?
done yet. No.
I'm not ready. I'm
You
still
start
writing
till
it down.
everybody's ready.
Oh my god.
19.
Everybody ready?
No.
Hold
I'm
on.
not ready.
Yeah.
Negative 237, x to the 15th, y to the 22nd, z to the 47th. That's 5 halves.
What?
So there's some things in there that you probably got to stop and think about how we want to answer. You cannot use your calculator. Ready? Go.
Oh, wait. Let me look at the board. So plus 7. No, would it be? No.
Are you talking to me or yourself or
Both.
both?
Yeah.
I don't understand gibberish. Me, all I got was me.
Oh, I did the wrong one.
I gotta erase this.
I cannot fit this.
Oh boy.
Next line.
Wait, what is X, Y,
Is that 14?
14?
Where?
Which one, is that Y to what? Is that, what is the Y to? On
Y
Y?
to the 30.
This one?
Yeah, the Y.
22nd. Z to the 47th. How'd I do?
I'm not done yet.
Come on in.
Keep going.
Start with 22 or 30.
I just did this.
Oh, I don't wait. Wait.
Starting next year. Just leave
Maybe
it.
65 X to the 8.
Oh.
Y
But
Bro,
That's kind of what I did.
Your answer got it.
What?
For the third one, is that 8 or 18 for Joe?
X to the 8th. 8, 16, and then 33.
It looks good.
are there gonna be problems like this on the test?
bro.
We should.
We have an extra credit.
Yeah, this should have been an extra credit. I kind of made the test kind of easy. Tell you
I
the
got
truth.
it. I got it right. Let's go. You put 22 over 3, I put 7.3. Yeah, you do. What? I got 1 variable.
Well, 10.3 is not right, so that's wrong.
7.3 repeating.
Yeah, that's
Same.
Okay, so those of you that are still working, that's fine. The numbers are definitely right. The coefficients, I don't know if I screwed up on any of the next ones.
I got the same numbers.
Okay. Well then, if we both got it, it's gotta be
I can do math, I just can't make
right. Here's why I kind of wanted to do this part right here. Starting from here on out, don't forget, leave it as 22 over 3. Okay? This start now will definitely want you to leave it as fractions.
Okay, now I can look.
Okay?
Yeah.
So don't turn that into a decimal, don't turn it, the only thing that she would want you to do is reduce it, and that just means to make it as small as I possibly can. Fractionals.
That hurt my head.
Yeah,
That's a good one, right?
it.
And the bad thing is, you look at it and it's kind of confusing. If somebody would walk in right now, they probably wouldn't really understand it, right? Because it just looks like a bunch of mumble jumble.
Let's go.
How'd we do there
That-
tonight?
That hurt my head.
You think you did good?
That hurt my head a lot.
So obviously that's just kind of fun, all right?